So now we're going to start into chapter 1. So this is the stuff that might not be review for you. So the earlier stuff I figured was probably mostly review. But this now, I'm fairly confident this won't be review for some of you. At least some of it might be review. Who knows? 1.1. So we're going to look at sets and coordinates. Your suggested exercises are 3, 11, 21, 23, and 33. And just a note that number 21 is going to require number 20. So you kind of have to look at number 20 to do number 21. The big topics are going to be the Cartesian coordinate plane, quadrants, different kinds of symmetry. So the symmetries we're going to look at are x-axis, y-axis, and origin. We've got two formulas, the distance formula, which is equation 1.1 in the book, and the midpoint formula, which is equation, surprise, 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 1.2 in the book. I'm going to ask you to work through some specific examples. So examples number 1, 2, 5, and 7 in the book. So before I was asking you to read the whole section, or I'd say skim this section or whatever. Now, skimming this section is always a good idea, but in particular, I'd like for you to work through these examples. And when I say work through, what I mean is look at the statement of the example. If it's totally clear to you how to do it, still at least try to go through it. Cover up their solution, see what you get. Then check it against their solution. If you get stuck, peek at the solution, and then try to go forward from there. But this is not just passively reading. Okay, so that's what I mean by work through. Pardon me. So, given 2 points, P1 and P2, we define the distance. And this is standard Euclidean distance, to be d P1, P2, or sometimes you might see absolute value of P1 minus P2. You're going to see it maybe written in different ways depending on where you look. And this is going to be the square root of x1 minus x2, quantity squared, plus y1 minus y2, quantity squared. I'm taking the square root of this whole thing. And this is where P1 has coordinates x1 and y1, and P2 has coordinates x2 and y2. So we're looking at the difference between the x values and the difference between the y values. Okay, so let's do an example. Find the distance from 3, 7 to 6, 3. Right, solution. We're going to plug in the distance formula. Now, I would recommend that you just start by writing the formula. So just write d equals, it's understood that we're doing the distance from this point to this point. So d equals x1 minus x2, quantity squared, plus y1 minus y2, quantity squared. And if you've seen this written as x1 minus x2 versus x2 minus x1 or something, it doesn't matter because we're taking the difference and squaring it. So don't worry about whether it's x1 first or x2 first. Just you've got this difference and this difference, okay? So now let's write down what that means for us. So this is going to be the first x value, so 3, minus the second x value, 6, quantity squared, plus the first y value, 7, minus the second y value, 3, quantity squared. And let's just keep going. So d is going to equal, well, this is the square root of 3 squared plus 4 squared, which happens to be the square root of 9 plus 16, which is the square root of 25, which is 5. So again, I cooked up this example to have a nice pretty number, and I will typically do that for you. I want to make sure that I'm not giving you too many nasty numbers if I can avoid it, because that just serves as a check. If you're getting a really intensely nasty number, then probably either I made a mistake or you made a mistake. And this way we don't need to use calculators. So if you understand the concept of how the distance formula works, then you should be able to do it with a calculator with nastier numbers. Let's move on. So here's the kind of example that that I really want you to be able to tackle. So this is two parts. So part A is find all the points at a distance of 2 from the point 1, 3. And part B is which of these points from part A lie on the y-axis. So let's do this. So solution for part A, I want to find all the points that are at a distance 2 from the point 1, 3. So what do I want to do? Well, I want to write down the distance formula. I'm going to leave a little bit of space. I want to write down the distance formula, and I want to say, well, this is going to be, x1 minus x2 squared plus y1 minus y2 squared, right? And so what am I doing? Well, I want to do the distance between any point and the point 1, 3. Moreover, I want that distance to equal 2. So I'm going to continue. I'm going to say the distance equals 2, and it is, well, my any point is just going to have coordinates x, y. So I've got x minus, and then the specific x coordinate for my point, x minus 1 quantity squared. And again, my sort of any point, which is just I'm finding points. What are the coordinates of a point? X, y. My other point has it's going to have y coordinate y, and then I'm going to subtract off the y coordinate from this point, and I've got this distance formula, and now look, I've plugged this 2 pardon me, I've plugged 2 into the distance formula. So now all I have to do is write this down. Now I could stop here, but I'm going to square both sides, and I'm going to get 4 equals x minus 1 quantity squared plus y minus 3 quantity squared. And this, any point that satisfies this equation will be at a distance 2 from our point 1, 3. And you may recognize this as this is the equation of the circle of radius 2 and centered 1, 3. So if you knew that, that's great. If you didn't know that, that's also okay. Just a little note. That's the equation of the circle with radius 2 and center 1, 3. So this is all the points, and you might say, well, wait, that's an equation. How is that a point? So this is any point with coordinates x, y that satisfies that equation will then be at a distance of 2 from that point. And I definitely, if this doesn't make sense, I recommend watching it over again and watching how it unfolds. But the main point is that I've got my distance, and what's the distance? The distance is the square root of this thing, right? It's the distance formula. So I plug in the distance between 2 points. Which points? Well, the point, x, y is kind of my variable, but it's 2 variables. It's just the random point wherever it is, and the point 1, 3. Okay, so I'm trying to find the distance between any point, x, y, and my special point, 1, 3. Now, I know that this distance has to equal 2, so that's where this 2 comes from, and I plug it in and I solve. Now, some people are going to solve this for y and they get a plus or minus or something, but this is fine for me right here. Okay, so part B. Now let's find which of these points from A. This was kind of poorly written here. which of these points from part A lie on, this part A, lie on the y-axis. So we're going to take the answer from part A, and we're going to find those points that are on the y-axis. Well, if it's on the y-axis, that means the x-coordinate equals 0. So we just plug x equals 0 into this equation. So we bring down our equation, 4 equals x minus 1 quantity squared plus y minus 3 quantity squared, and we plug in x equals 0. So 4 equals 0 minus 1 quantity squared plus y minus 3 quantity squared. All right, let's just solve. We get 4 equals negative 1 squared is 1 plus y minus 3 quantity squared. Well, let's keep solving. And I get 3 equals y minus 3 quantity squared. Take the square root of both sides. And I get root 3. Do I get root 3? So I take the square root of both sides, but this was a square root of something squared. I'm going to need plus or minus here. Just remembering literally, well, it's going to be yesterday's lecture for you. It was a lecture that I gave this morning or recorded last night, however you want to say it. But remembering how many roots something has. So that's this thing right here. When I'm solving a squared equals, I need to do that. So I've got this plus or minus 3 equals, plus or minus the square root of 3 equals y minus 3. I add 3 to both sides, and I get y equals 3 plus or minus the square root of 3. Am I done? Not quite yet. I need to combine this and this to get my final answer of the points are 0, 3 minus root 3 and 0, 3 plus root 3. And that's my final answer. And if this was a bit mysterious, that's okay. You can watch it over again, but I also want to draw a little picture to kind of explain what's going on here. So in part A, we looked at the point 1, 3. Oh, you know, I've got these nice lines here. What am I doing? There we go. In part A, we wanted to find the points that were centered at 1, 3, which is right here on these little axes that I've drawn. And we wanted to find the points that were distance 2 away from this. Well, guess what? The points that are distance 2 from this are going to form a circle of radius 2, right? Let's make that circle just a little bit bigger. It's not quite, but it's close enough. So we want to find, I didn't graph the point, or sorry, I graphed 3, 1, not 1, 3. Sorry about that. 1, 3 is going to be right here. So we're looking for the set of points that are distance 2 from this point right here, and this is exactly a circle of radius 2. I just having a hard time getting my little pretty circles. There we go. Got my pretty circle going. So now part A gave us the equation of this circle with radius 2 and center 1, 3. So this is a circle with radius 2. Here, this is 2. And the center is 1, 3. 1, 3. Boom. My 2 got a little funny. Okay. Wonderful. That's great. Now, which points are on this circle and on the y-axis? Those are going to be this point right here and this point right here. And what we notice is it's 3 plus or minus something just a little bit less than 2. And this gap we're going to notice is root 3. So it's 3 plus root 3 or 3 minus root 3. That's how we get the points 0, 3 minus root 3 and 0, 3 plus root 3. That's sort of geometrically what's going on. So what did we do? We knew that this was the equation that gave us the circle, that gave us this circle here. And so we just wanted to find which points are on that circle and on the y-axis. Well, y-axis means x equals 0. So we plug in x equals 0 into this formula here, and it gives us some equation, which we solved. We got y equals 3 plus or minus square root of 3, and that gave us our 2 points. Okay. So that was a bit involved, but hopefully not terrible. So next I want to talk about the midpoint. So the midpoint of P1 and P2 is the middlemost point on the line segment connecting them. That's what we call the midpoint. The equation for midpoint is going to be if, or a formula, I guess it's not really an equation. If P1 is, x1, y1, and P2 is x2, y2, then their midpoint has coordinates, and this is a little easy. This is easy to mess up, but it's going to be x1 plus x2 divided by 2, and y1 plus y2 divided by 2. Now, a lot of times people want to do x1 minus x2, y1 minus y2, because it looks like some sort of a difference thing or distance thing. But what we're actually doing is averaging the x coordinate and then averaging the y coordinate. So let's do a quick example. Find the midpoint of, let's do 4, 5 and 2, -1. Okay, so let's find this midpoint, and that's going to be, well, we plug it in. So we know the midpoint is going to be x1 plus x2 over 2, y1 plus y2 over 2. And what's that? That's going to be 4 plus 2 over 2, 5 plus a -1 over 2, and this becomes 6 over 2. 5 plus a -1 gives me 4 over 2, and this is just 3, 2. That's going to be the midpoint. Okay? So the last thing that I want to discuss here is symmetries. So I guess I'll just do a new page. So for symmetries, we've got these 3 different types of symmetries. So I have let's do it with coordinates, just cause why not? It just does not want to stay right on the grid, does it? Well, okay, we're gonna do our best. So if I have some point and I want to make this point intentionally offset a little bit, so this is the point. This is the point that I wanted to make last time. This is 3, 1. So we're going to say that x, y is our original point. It is symmetric. I'm going to write this out with respect to this. I'm going to be writing as WRTO, WR2, with respect to the x-axis with so if I think about this point and I reflect it over the x-axis, it's going to be symmetric to sort of the mirror image over the x-axis is going to be the point x, -y. Okay, and in this case, it's going to be x-axis symmetric with respect to, wow, I'm really having a hard time with the letters. Symmetric with respect to x-axis 3, -1. So xy is our original point, ... It's symmetric to the x-axis, or with respect to the x-axis, with this point. It's symmetric with respect to, so I'm doing this all abbreviated, the y-axis with, so xy, it would be negative x comma y. So in our case, if we were to flip this over the y-axis, we would have this point, negative 3 comma 1. And finally, it's symmetric with respect to the origin with negative x, negative y. So that's where we hit both with where we hit both coordinates with a minus sign. So one way to view this is like it's going through the origin to its sort of opposite, but so it's negative 3 comma negative 1. But for me, I think it's a little bit more helpful to imagine that the whole board is shifting, the whole coordinate plane is shifting 180 degrees. It's shifting all the way around. That's kind of how I like to think about it, is that we're rotating this Cartesian coordinate plane, just giving it a half turn. By the way, and I should have mentioned this xy coordinate plane we call the Cartesian coordinate plane, named for Descartes, who, as Lore would say, was having a fever dream and watching a fly crawl across his ceiling and said, well, I bet I could describe the precise location of that fly with two numbers, and those became x and y coordinates, according to legend. So this is symmetric with respect to the y-axis, and this is symmetric with respect to the origin. Okay, so here's an example as well as our definitions. So y-axis, origin, symmetries, and hopefully you've seen something like this before, but hopefully this makes some sense, and talk